Imagine slipping on a jacket that knows when you're cold before you even feel it, and automatically adjusts to warm you up. Or a t-shirt that tracks your heart rate, hydration levels, and even stress, all without wires, batteries, or bulky sensors. Imagine socks that optimize circulation during long flights, or pants that adjust pressure points to support spinal alignment throughout the day. Picture hats that regulate scalp temperature and gloves that identify early signs of arthritis flare-ups. Think about scarves that react to ambient noise and transform into noise-dampening hoods or shawls. Sounds like science fiction? Not anymore. Thanks to artificial intelligence, smart fabrics are poised to revolutionize the clothes on your back and redefine what we expect from apparel. From intuitive thermal control to proactive health monitoring, and from fashion innovation to sustainable design, we are standing at the edge of a textile revolution. Subscribe, hit the notification bell, and like this video if you're curious about how AI is transforming the very threads we wear. This is Tech Mythos. Traditionally, material science has been a slow, methodical process. Discovering a new textile with novel properties could take years of trial-and-error experimentation. Scientists might test thousands of molecular combinations just to find one that behaves as intended. But now, AI is compressing that timeline by orders of magnitude. Through advanced machine learning algorithms, neural networks, and access to massive materials datasets, AI can predict how molecules will behave, simulate fabric structures, and even generate entirely new material blueprints that human scientists might never consider on their own. AI can model how polymer chains interact under extreme conditions, how nanofibers respond to heat and friction, and even how a finished garment will drape on the human body during movement. This means researchers can design textiles from the molecular level up, customizing properties like elasticity, breathability, strength, and conductivity. Entire generations of experimental fabrics that would have taken decades to prototype can now be modeled, optimized, and stress-tested virtually. These insights are now being fed back into automated manufacturing pipelines, enabling rapid prototyping and refinement cycles that were previously impossible. Take, for instance, a groundbreaking project led by MIT's Institute for Soldier Nanotechnologies. Researchers there are using AI to develop fabrics that can change their structure in real time, responding to environmental triggers like heat, moisture, or electrical signals. These materials are being engineered to respond as intuitively as your own skin. The result? Clothing that adapts dynamically to your body and surroundings, whether you're scaling a mountain or simply walking to work. These innovations are being studied for military and space exploration applications where conditions change rapidly and human performance can hinge on adaptive equipment. In one remarkable case, AI-designed materials embedded with thermo-responsive polymers can expand or contract at the fiber level depending on ambient temperature. That means your clothes could ventilate when it's hot and insulate when it's cold. No buttons, no toggles, no apps, just seamless, invisible comfort. These polymers are designed at a molecular level to react precisely and repeatedly, withstanding countless cycles of change without degrading performance. Advanced fibers can even record how often these changes occur, allowing your clothes to learn your comfort patterns and proactively adjust in anticipation of your needs. But it doesn't stop at temperature regulation. Smart fabrics are also becoming biosensors capable of real-time physiological monitoring. At Stanford, researchers recently unveiled a textile embedded with AI-enhanced nanofibers capable of reading biosignals like ECG, EMG, and galvanic skin response. This wearable fabric isn't just passively collecting data, it's interpreting it using embedded machine learning models. The AI models, trained on thousands of physiological patterns across various states of activity, can distinguish between normal fluctuations and early signs of stress, fatigue, or even potential medical anomalies. This type of early warning system could transform healthcare, turning everyday clothing into continuous diagnostic devices. Imagine athletes wearing shirts that detect micro-fatigue in muscles before injuries occur. Or firefighters whose uniforms sense dehydration, elevated heart rate, or carbon monoxide exposure and send alerts to their team in real time. These aren't distant possibilities, they're currently in advanced prototype stages and are being tested in controlled environments for future deployment. Smart uniforms for soldiers, miners, and medical professionals are also in development, designed to log exposure to harmful agents and environmental conditions, potentially saving lives. One of the most impressive and commercially viable advances comes from a startup called Scienta, which leverages AI to design conductive inks that can be printed directly onto fabric using precision micronozzles. These inks allow circuits to be integrated into textiles without compromising softness, stretchability, or breathability. Combined with flexible microprocessors and low-energy AI chips like those from ARM, Qualcomm, or Intel's Loihi line, these garments can process data on the fly, adapt based on context, and even communicate wirelessly with other devices. Some clothing now includes flexible memory modules, enabling your wardrobe to retain preferences, biometric data, or even digital IDs. This integration of intelligent circuitry into fabrics marks a paradigm shift. We're no longer talking about gadgets you wear. We're talking about fabric becoming the platform itself. Shirts that detect emotional states and change color accordingly, jackets that vibrate to deliver notifications, and pants that log your posture and provide real-time suggestions to correct your form. Developers are even working on garments that deliver guided meditation prompts or biofeedback vibrations for stress relief. In fact, we're beginning to see the convergence of edge computing and wearable fabrics. The ability to run localized AI inference on embedded processors means your clothes can analyze biometric signals, environmental conditions, and movement data without relying on cloud servers. This enables faster responses and greater privacy. It also allows wearables to function in remote environments, like backcountry expeditions, outer space, or disaster zones, without a constant data connection. These self-sufficient garments can keep functioning even in offline emergencies, potentially alerting emergency responders with embedded GPS and distress protocols. If you're finding this fascinating, subscribe to Tech Mythos, share this video, and tell us in the comments, what kind of smart clothing would you actually wear? Let's pivot to sustainability. AI isn't just enhancing functionality, it's making fabrics greener and more ethical. Companies like Polybion, Bolt Threads, and Modern Meadow are using AI to engineer biodegradable, lab-grown alternatives to cotton, leather, and polyester. These materials are designed not only to perform better under stress and wear, but also to decompose safely in landfills or even compost bins. AI is used to optimize protein synthesis pathways, fermentation cycles, and fiber strength, drastically reducing the resource footprint of traditional fabric manufacturing. AI models also help reduce waste during the design and production process. Digital twin simulations allow designers to preview how fabrics will behave under stress, friction, and environmental conditions. This leads to better prototypes, fewer physical samples, and a dramatic cut in wasted resources. Some manufacturers are even using reinforcement learning to teach robotic looms how to weave optimized fiber geometries for maximum strength and minimum material use. There's even talk of fully autonomous AI-run factories that spin, dye, cut, and stitch smart garments based on real-time demand data. These systems could eventually allow local microfactories to produce garments on demand, drastically reducing shipping emissions and overproduction. And then there's the fashion-forward side of this revolution. Designers are using generative AI tools like Runway, Dall-E, and Clo3D to create responsive fabrics that shimmer, shift color, or change patterns in real time. These aren't gimmicks, they're powered by AI models that detect environmental cues such as sunlight or motion, or respond to biometric feedback, activating micro-actuators embedded within the fibers. Imagine a dress that shimmers gold in sunlight, shifts to blue in shadow, and turns translucent when you start dancing. Fashion becomes dynamic, personalized, and even emotional. Some designers are even using these materials to create wearable mood rings. Outfits that pulse with ambient lighting in time with your breathing or softly display scrolling messages based on your location or emotion. It's a whole new canvas for creative self-expression, and it's programmable. Event organizers are also experimenting with dynamic uniforms that light up during concerts or glow based on crowd movement, turning entire audiences into interactive displays. What makes all this possible is the convergence of AI with nanotechnology, wearable computing, sustainable materials science, and real-time data analytics. It's not just about embedding sensors, it's about teaching the fabric itself to sense, think, and adapt. And that requires training deep learning models on terabytes of environmental, physiological, and mechanical data to create context-aware garments that evolve with the user. Open-source platforms are also emerging, enabling developers to prototype their own AI fabrics using modular toolkits. At the University of Toronto, one ambitious project is training transformer models to predict wear and tear on fabrics by simulating years of use in just a few hours. This kind of predictive modeling enables the development of textiles that resist abrasion, deform intelligently under stress, and maintain their biosensor integrity far longer than traditional materials. In the future, these models could even suggest real-time repairs using embedded nanobots or self-healing polymers. Imagine a coat that notifies you of a tear, seals it automatically, and logs the incident to optimize future designs. Another exciting breakthrough involves AI-driven customization. Imagine scanning your body once and having clothes 3D printed in smart textiles that fit perfectly, optimize temperature zones, correct posture, and even support muscle groups during physical activity. This isn't just smart fabric, this is smart tailoring on demand, and it's already happening in pilot programs in Asia, Europe, and even parts of North America. Some companies are testing body-adaptive garments that change shape throughout the day based on your activity and fatigue level. Luxury brands are exploring adaptive couture that molds to each individual body in real time. These fabrics also open up incredible possibilities for accessibility. For people with disabilities, AI-enhanced garments can offer haptic feedback for navigation, voice-controlled adjustments, real-time vitals monitoring, or even speech-to-text functionality via textile-based displays that light up words on your sleeve. Imagine someone with hearing loss receiving real-time text transcriptions directly on their jacket arm, or a visually impaired individual guided by directional haptic pulses stitched into their coat. Other possibilities include garments for children with sensory sensitivities that adapt texture, pressure, and temperature based on their comfort levels, or clothing that serves as a communication device for nonverbal users by converting gestures into digital commands. Smart fabrics may also play a role in elder care, with garments that monitor blood pressure, detect falls, or remind wearers to take medication via gentle vibrations or soft audible cues. Still, there are undeniable challenges. Battery life, data privacy, durability under repeated washing, electromagnetic interference, and consumer price points remain significant hurdles. But AI is helping here too. By optimizing power efficiency, compressing neural networks to run on edge devices, simulating real-world wear conditions, and enabling on-demand diagnostics, researchers are closing the gap between lab and wardrobe. Efforts are also underway to create energy-harvesting fabrics that generate power from movement, heat, or even sunlight to eliminate the need for external batteries altogether. New biodegradable conductive materials are also being developed to keep this tech sustainable from end to end. Soon, the question won't be if your clothes are smart, it will be how smart, how intuitive, how stylish, and how seamlessly they integrate into your lifestyle and identity. Will they change color based on your mood, alert you to illness days before symptoms appear, double as interactive displays or gesture-based controllers, help your posture, guide your workouts, protect your privacy, and express your identity all at once? If AI continues at its current pace in materials science, the answer is yes, and it will arrive much sooner than you think. This isn't wearable tech as an accessory. This is wearable tech becoming the fabric itself, thread by thread, line by line, sensor by sensor. Thanks for watching. If you want more future-forward content about where technology is heading, subscribe to Tech Mythos. Like this video, share it with your friends, and let us know in the comments. What kind of AI-enhanced clothing are you most excited for? See you in the future.